What's up, guys? It's me, Sir Ernest, and today we're going to solve problem 8.1a of Fowles and Cassiday, 7th edition. So the problem reads, find the center mass of a thin wire that is bent in the form of a three-sided block shape U with each segment of equal length B. So as mentioned here, each side of this three-sided block shaped U is of equal length, and that length is B. So that means this is B. So for symmetry, we're going to put the y-axis at the center between these two vertical wires or segments so that this length is B over 2. Also, let's label these segments as 1 and the center mass as we calculated before. Center mass of this segment is at the middle. So let's call this segment number 1 because the center mass is at the middle. So we can treat this as a particle whose mass is located at this point. Same goes for this segment. So let's call this segment segment number 2. And this segment is segment number 3. So you will notice that the representative particles whose positions are as follows. Segment 1 is at negative b over 2, and then the y component would be at b over 2. Position number 2 would be b over 2 and b over 2. So this is b over 2. This is also b over 2. So this is also b over 2. This is b over 2. And lastly, the particle that represents the bottom segment, segment number 3, is at the origin. So therefore, this problem will now be reduced to a system of 3 discrete particles. And because we said that this object is along the xy plane, so therefore, the z component of the center mass would be equal to 0. The x component will be equal to the sum of xi, mi, or sum of mi. If, for example, each segment has mass m, this segment has mass m. So let's call this m1 will be equal to m, m2 will be equal to m, and then the third segment has mass m3, and this is equal to m. So therefore, the sum of the masses of the three segments would be 3m. So this becomes 1 over 3m times m times b over 2. So this is bm over 2. For segment number 2, this is m times b over 2. So that's bm over 2 as well. And then this one would be 0 times m, or 0. So the xem, sorry, this should be negative because it's on the left. So let me just fix that for you. This and this will cancel. So therefore, this is 0. And for ycm, we do the same. So sum of yi, mi over sum of mi, and is equal to 1 over 3m times this one. So this is b over 2 times m. So that bm over 2. And then second segment, would be the same. It's m times b over 2. So that's bm over 2. This is 0. So the result here is, so remember that m will cancel. So this is b over 2 plus b over 2 would be b. So this becomes b over 3. So the center of mass will be along the y-axis, and it will be somewhere 1/3 from the x-axis. 1/3 b from the x-axis, so it's somewhere here. So that's it. That's problem 8.1a of Fowles and Cassiday. The center of mass of this thin wire bent into the form of a three-sided block shape U with each segment of equal length B is found at x equal to 0, y equal to b over 3, and z equal to 0 if we set this wire to be on the plane of x, y axis. That's the end of this solution. I hope you learned something today. In the next video, we're going to solve more problems on the center of mass. Thank you guys, and I'll see you guys in the next video. Bye-bye.